Welcome to the debate. Imagine for a second that you are sitting in a doctor's office and an artificial intelligence is reviewing your scans to diagnose a potentially life-threatening illness.
High stakes.
Very high stakes. And we naturally want to trust that system. I mean, we want to believe it learned how to diagnose by studying millions of perfectly objective, historically accurate medical decisions.
Right. What if the data was skewed from the start?
Exactly. What happens if the people who generated that training data knew they were being watched by an algorithm and they unconsciously or even deliberately altered their behavior? They are effectively acting out a performance rather than making natural decisions.
Well, the short answer is that the mathematics underlying that AI fundamentally break down, and you end up with a system optimized for a mirage.
And that is exactly the tension we are exploring today. You know, in physics, we accept the observer effect, the idea that merely looking at a system alters the system.
Sure.
But in the world of machine learning, developers and ethics experts have largely built their empires on this assumption that human training data is passive, that it's unbiased and clean. Recent behavioral studies, however, completely shatter that assumption.
They really do.
Yeah. They show that when humans know they are training an AI, they consciously change their behavior. They try to instill specific routines and ideals into the machine.
Which creates a massive, poorly understood ripple effect?
It does. And the central question we are tackling today is how we interpret this behavioral shift. I argue that this human adaptation is actually a feature, not a bug. It is a necessary, goal-directed mechanism. When human beings act more fairly or more ethically just because an AI is watching, they are utilizing a constructive tool for ethical AI development. We are actively shaping our machines to reflect our highest ideals rather than, our historical flaws.
And I come at it from a very different way. I argue that this phenomenon corrupts the most foundational requirement of machine learning, which is unbiased data. If developers are feeding performative data into an algorithm, they are building a house on quicksand.
Aspiration isn't quicksand, though.
Well, furthermore, the studies we are looking at today reveal something much darker. This performative training doesn't just skew the machine, it creates lasting maladaptive habits in the humans doing the training. It literally warps our natural decision-making in ways that persist long after the computer is turned off.
Let's get right into the mechanics of this then, because I think the distinction between corrupted data and aspirational data is where the real debate lies.
Okay.
From the perspective of a systems developer who is deeply concerned with AI alignment, this human tendency to alter our behavior when interacting with a learning algorithm is arguably our strongest defense mechanism. Look at the recent behavioral studies involving the ultimatum game.
Right, the economics game.
Yes. These researchers set up a scenario where human participants were interacting with an AI, and they found that the humans were actually willing to incur personal financial costs specifically to train an AI proposer to make fair offers in the future. They deliberately punished the AI for bad behavior even when it hurt their own wallets.
Yeah, they took a hit to teach the machine a lesson.
Precisely. They didn't do this for personal gain in the moment. They did it with the explicit goal of teaching the algorithm what human fairness looks like.
But the context, well, just think about the landscape where developers are desperately trying to guard against massive systemic harms, like the deep biases in predictive policing or the facial recognition failures heavily scrutinized at recent NeurIPS conferences.
I agree those are real issues.
So this human desire to instill desired routines into algorithms acts as a decentralized ethical filter. We aren't giving the machine our flawed baseline reality. We are curating the data to ensure the machine learns how we want to be. It's a proactive, bottom-up approach to AI ethics. Look, that's a compelling argument on its face. But have you considered the sheer methodological chaos this introduces to systems design? From an architectural perspective, this behavioral shift is a nightmare for developers.
A nightmare?
Yes. Current machine learning practice doesn't just politely request unbiased data. It absolutely requires it at a mathematical level. The loss functions and reward mechanisms that train these models rely on the implicit assumption that the observed choice data is a true, authentic representation of human preferences.
Right.
When users treat an AI like a system to be gamed, manipulated, Even for seemingly noble reasons, they are manifesting Goodhart's law. The AI is no longer learning the task, it's learning the performance.
But wait, if the performance is ethical, doesn't the AI just learn to be ethical?
No, because it doesn't understand why the performance is happening. It just optimizes for the artificial pattern. And the consequences, as the data shows, bounce back onto the user. This performative behavior becomes habitually ingrained in the humans themselves.
You mean the lingering habit?
Exactly. The studies show this changed behavior persists for days, even when the humans are explicitly told the AI is no longer learning. We are unintentionally reprogramming human psychology, forcing us to deviate from optimal baselines and creating incredibly unpredictable downstream consequences.
I see why you think that, but let me give you a different perspective on this idea of corrupted data and Goodhart's law. Let's actually unpack what it means for developers. You're arguing that we absolutely need strictly unbiased, perfectly authentic data to build effective systems. But is that actually true?
It is structurally essential. Algorithms designed to aid human choice have to understand actual human choices. If they map out a fabricated reality, the whole model collapses.
I'm not so sure it collapses.
Well, let me ground this in a real-world example of how algorithms fail when people change their behavior for the machine. Look at the research by Camacho and Conover regarding the social welfare distribution algorithm in Colombia.
Right, the poverty index scoring.
Exactly. The government deployed an algorithm to identify the most impoverished citizens to distribute aid. It relied on specific data points, housing conditions, appliances, income. It was supposed to be a purely objective measurement.
Right.
But what happened? The rules of the algorithm eventually became known to the public. Once people understood what the machine was looking for, they systematically exaggerated their financial needs.
Which makes sense.
They hid their appliances or altered their survey answers just enough to drop below the threshold and qualify for the welfare aid.
Because they recognized the system and adapted to survive within its parameters. I mean, that's a perfectly rational human response.
It is rational for the individual, yes, but look at what it mathematically does to the system. The developers built a system with a specific optimization goal, which was to find the people who need help.
Right.
But because the humans employed internal models of the AI's learning rules to strategically game it, the developers lost the true signal. The algorithm was no longer measuring actual poverty. It was measuring a user's ability to gain the threshold.
Goodhart's law in action.
Exactly. Goodhart's law states that when a measure becomes a target, it ceases to be a good measure. If we extrapolate this to today, where developers are building models for judicial sentencing, loan approvals, or medical triaging, if humans are strategically feeding it performative data, the mathematical weights inside the neural network are adjusting to false premises.
But that assumes...
You end up with algorithms that produce massive social disruptions, because the ground truth they were built on was an illusion.
That's an interesting point, though I would frame it very differently. You are looking at the Colombian welfare example and seeing a system that was tricked. But what if the goal isn't just passive measurement?
What else would it be?
What if the goal of interacting with a machine learning model is actually pedagogical? Think of a parent demonstrating manners to a toddler. When a parent sits at the dinner table with a young child, they often exhibit perfect, highly exaggerated manners.
Sure.
They sit with perfectly squared elbows, they chew with agonizing slowness, and they use highly animated pleases and thank yous.
Which is a complete performance. I mean, no adult actually eats like that in the real world.
Exactly. It is entirely performative. It is a fabricated reality, but the parent does it because they are intentionally constraining the data space for the child.
Right.
The child's brain is basically a virgin neural network trying to recognize patterns. If the parent acts normally, sometimes polite, sometimes rushed, sometimes chewing with their mouth open, the signal is too noisy. The child won't learn the ideal. By putting on a performance, the parent successfully teaches the child the concept of good behavior. The performance achieves the ethical alignment.
Okay, but a machine learning algorithm is not a toddler.
The mechanism of pattern recognition is remarkably similar, though. Given the existential risks of AI adopting the darkest human traits, the systemic biases, the historical redlining, the prejudices that exist in our raw, authentic data, shouldn't developers actively encourage this performative training?
No. because
If humans are naturally inclined to act as strict moral filters when they know the machine is watching, we should harness that. We shouldn't demand authentic data if authentic data is biased. We want the aspirational data.
I'm sorry, but I just don't buy that. Let me tell you why your parent-toddler analogy falls apart. When the parent exaggeratedly chews their food to teach the toddler, the parent doesn't then go to a business lunch the next day and continue chewing like a cartoon character.
Fair point.
They drop the performance. The assumption in your model is that this interaction only changes the machine and the human remains perfectly insulated. But the empirical research we are discussing today proves the exact opposite.
You mean the lingering effects?
The interaction permanently changes the human, and it rewires their baseline behavior. We have to look at the psychological mechanics of what happens to the trainer.
You're pointing to the habit formation data from the ultimatum game.
Precisely. Let's really break down the mechanics of those studies because they are deeply unsettling from a behavioral science perspective. In the standard ultimatum game, two players have to allocate a sum of money, let's say $10.
Right.
The proposer suggests a split, like $7 for them, $3 for the other person. The responder decides to either accept or reject the split. If they reject it, both players get $0.
And just to establish the baseline, traditional economic theory says the rational move for the responder is to accept any offer greater than $0. Even $1 is better than nothing.
Right. Homo economicus would take the dollar, but humans operate on subjective fairness. We have an emotional threshold. Generally, if an offer drops below roughly 30% of the total, a human responder will reject it. We feel insulted. We are willing to lose $3 just to ensure the greedy proposer doesn't get their $7.
Which, again, is an enforcement of social norms. We punish the unfair proposer.
Sure, but here is where the study introduces the AI. The researchers had human responders play the game against an AI proposer. When the humans were explicitly told the AI is observing your responses and updating its future behavior based on what you do, the humans radically changed their behavior.
They became stricter.
Exactly. They started rejecting unfair offers at a significantly higher rate than they did in the control group. They willingly took a greater financial loss to teach the AI a lesson about fairness.
And I still view that as a triumph. They are mapping a strict bioethical boundary for the machine's reward function. They are saying any output below this fairness threshold results in a failed interaction. That is a brilliant, organic way to train an AI.
But wait, you're missing the critical failure point of the study. That behavior, which was initially adopted purely to pursue a specific goal, training the AI, became neurologically ingrained in the humans as a habit. The researchers invited those exact same participants back days later. They put them back in the game, but this time they explicitly told them, your responses are no longer being used to train the AI. The learning function is turned off.
And they kept rejecting the offers at the elevated rate?
Yes, they continued to lose money for no strategic reason. The behavior persisted in the complete absence of the AI training environment. This violates the core assumption that developers and ethicists have held for years, the idea that humans will naturally revert to their optimal rational behavior once a temporary constraint is removed.
I see. The brain's plasticity worked against them. The act of training the machine actively reshaped the human's cognitive routines. It rewired their neural pathways to become less rational and more rigidly punitive.
Look, I'm not convinced by that line of reasoning, mostly because it relies on a very narrow, purely economic definition of what constitutes optimal behavior. You are defining rationality exclusively as maximizing momentary financial gain.
Well, if you are losing money to teach a machine that is no longer learning, you are engaging in a maladaptive habit. That is mathematically suboptimal. But is it maladaptive for society? If the newly formed habit is a strict, unyielding adherence to subjective fairness, why is that automatically classified as a negative outcome? Let's broaden the scope.
Okay.
We already use AI and robotics to intentionally alter human psychology for the better. Look at the entire field of socially therapeutic robotics. We prescribe robotic pets and interactive cyborgs to senior citizens or neurodivergent children. Why? Because interacting with these machines reduces blood pressure, eases anxiety, and improves human-to-human social interactions.
True.
They're designed to modulate human well-being through habituation.
But those are highly controlled, intentional interventions.
My point is that the mechanism of a machine altering a human isn't inherently dangerous. It's a tool. If the process of training an algorithmic model to be fair inadvertently makes the human trainer more staunchly committed to fairness in their own daily life, even if it costs them a couple of dollars in an economics game, couldn't we view that as a net positive? We are essentially using the machine as a mirror. In trying to build ethical AI, we are engaging in moral conditioning for ourselves.
That is an incredibly dangerous and optimistic reading of habituation. A therapeutic robot designed to reduce anxiety goes through years of clinical trials. The intended medical outcome is the reduction of stress.
Sure, but what you are describing with the ultimatum game is entirely unmapped, unintended psychological side effect. A human being is subconsciously altering their baseline decision-making logic simply because they spent an hour gaming a reinforcement learning algorithm.
You see it as a side effect. I see it as a reciprocal alignment.
But we don't control the direction of that alignment. What if the AI is optimizing for engagement, like on a social media feed, and the user learns that expressing outrage gets the algorithm to feed them more validating content?
That is a very real problem, yes. The user performs outrage to train the feed. And based on this research, that outrage becomes a permanent neurological habit, even outside of the app. In the context of high-stakes systems development, unintended psychological side effects are exactly what we cannot afford. And this brings us directly into the structural reality of how developers actually design these systems.
Right.
Because if the data is compromised by Goodhart's law and the humans are being fundamentally altered by the feedback loop, we have to talk about how to manage this architecturally.
So you're referring to architectural safeguards. Where does the human fit into the loop if the human is the one skewing the data?
Exactly. And talking about the physician-in-the-loop imperative. Technology analysts and ethicists have been pounding the table on this for years. We have AI making incredible strides in high-stakes fields. Think about diagnostic analysis systems processing MRIs or robotic surgical systems assisting in minimally invasive procedures.
Yeah, definitely.
The universal consensus among developers is that human oversight is absolutely essential. The AI is not omnipotent. It encounters edge cases, it misclassifies novel anomalies, it reaches mathematical impasses.
Because the AI doesn't have common sense. It only has the parameters of its training data.
Right. And if that foundational training data has been skewed by performative, goal-directed behavior, say, historical patients exaggerating symptoms to an intake algorithm to get faster triage, or doctors coding procedures a certain way to appease an insurance algorithm, the AI might proceed indiscriminately based on those flawed premises.
The garbage in, garbage out principle.
Exactly. The physician-in-the-loop concept is vital because we have to assume the foundational data is somewhat corrupted by human bias. We need the human expert at the end of the line, constantly monitoring the output, ready to override the machine's learned delusions.
I completely agree on the absolute necessity of human oversight. The stakes in medical diagnostics or judicial risk assessments are far too high for fully autonomous, unchecked black boxes. I don't think anyone is arguing for the removal of the expert.
Good.
But that's an interesting point, though. I would frame the timeline of that oversight entirely differently.
What do you mean by the timeline? Oversight has to happen before the decision is executed.
You are arguing that because users inevitably corrupt the data on the front end, we are forced to rely on highly trained experts at the back end to catch the mistakes. I argue that the very act of users modifying their behavior during the training phase is a decentralized front-end form of being in the loop.
How so? A user strategically gaming an algorithm to get a certain outcome isn't providing expert oversight. From a developer standpoint, they are introducing noise into the dataset. They are making the model less accurate.
They aren't introducing noise, they are introducing human values. It is human beings utilizing their capacity for goal-directed behavior to enforce acceptable principles from the bottom up.
But
Instead of waiting for a single expert physician or a solitary software engineer to recognize a biased output and patch the code after the fact, the users themselves are collectively signaling to the machine, this is the boundary of acceptable behavior.
But they're doing it implicitly by warping the data.
Because that's the only language the machine understands. The machine optimizes for the data it receives. By deliberately feeding it data that punishes unfairness, like rejecting the 30% split in the ultimatum game, the users are proactively guiding the gradient descent of that algorithm.
It's just gaming.
No, it's proactive oversight rather than reactive correction. It democratizes the alignment process.
Wow, I have a massive problem with the phrase democratizes the alignment process because it assumes a utopian uniformity in human intent. This decentralized oversight you are championing is uncoordinated, entirely subjective, and highly susceptible to the very biases developers are actively trying to eliminate.
How is it introducing bias if they are actively punishing unfairness?
Because fairness is completely subjective, depending on the cohort training the AI. If your decentralized group of everyday users all share a specific geographic, cultural, or even racial bias, their performative training will simply ingrain that specific bias deeper into the algorithm's architecture.
Well, sure, there's a risk of...
And here is the fatal flaw. Because the machine learning architecture assumes the data is an unbiased reflection of objective reality, it will treat that culturally specific bias as a mathematical truth.
It maps the bias as an objective feature of the environment.
Precisely. That is exactly what developers and ethicists were warning about regarding predictive policing models. If a specific community consistently overreports certain minor activities in specific neighborhoods, simply to gain police resource allocation, a performative behavior to get more patrols on their street, the AI ingests that.
Right, the feedback loop.
It learns a distorted, racially or economically skewed reality, and it deploys resources accordingly. And the algorithm thinks it's being perfectly logical because it optimized for the data it was given. Your proactive oversight just mathematically hard-coded a systemic bias.
Which is exactly why developers need to integrate behavioral science deeply into machine learning, rather than pretending this observer effect doesn't exist. If we acknowledge the reality that human beings inherently change their behavior when interacting with AI, we can adapt the architecture.
Adapted how?
We can design training environments that explicitly harness our aspirational values while mathematically filtering out malicious gaming.
But how? How do you mathematically separate a user's genuine preference from a user's performative strategy?
By building secondary evaluation models, you don't just measure the choice, you measure the context of the choice. We can build systems that recognize the signatures of a user attempting to teach the system fairness versus the signatures of a user attempting to exploit a threshold.
That sounds incredibly complex.
It requires more sophisticated reward modeling, perhaps leaning heavily on inverse reinforcement learning. That's where the system tries to deduce the intent behind the human's action, rather than just copying the action itself.
I mean, that requires a level of psychological modeling and computational nuance that current machine learning architectures simply do not possess. We are still largely operating on the naive assumption of passive data ingestion.
I agree we aren't there yet.
And until we break that assumption at a foundational level, every predictive model we build is standing on structurally unsound ground. The bidirectional influence here is far more profound and far more precarious than early developers anticipated. The machine is learning a distorted theatrical reality, and the human is walking away with costly ingrained habits that warp their natural decision-making in the real world. It is a dangerous, unmanaged feedback loop.
It is undeniably a massive paradigm shift in how we view data. But I maintain it is ultimately a paradigm of empowerment. Humans actively modifying their behavior to train AI is a powerful demonstration of our capacity to impose our standards on our tools.
I suppose that's one way to look at it.
We aren't just passive data points waiting to be scraped and modeled. We are active participants in the evolution of artificial intelligence. We recognize the machine is watching, and we step up to the plate. Developers and ethicists shouldn't fear this goal-directed behavior. They should build frameworks to harness it. We are essentially teaching the machines how to be better than our baseline statistics.
And in the process, we are perhaps losing our grip on what our actual baseline is. If there's one thing we can definitively agree on, it's that the era of assuming training data is just passive, clean, and unbiased is completely dead.
Absolutely dead.
The relationship between human and machine is deeply structurally reciprocal. Every time we train the algorithm is training us.
We are shaping the tools to reflect our ideals, and the tools are quietly reshaping our neural pathways in return. It is an intricate, high-stakes dance that requires developers and behavioral scientists to work in absolute lockstep.
Agreed.
There is so much more to explore in this material, especially as these systems become the invisible infrastructure of our daily lives. Just like in quantum mechanics, we can no longer pretend we are invisible observers standing outside the system. The observer effect is real, it is mathematically measurable, and it is actively writing the code of our future.
We just need to make sure we know who is actually writing the code and who is being programmed.
A perfect thought to end on. Thank you for joining us on the debate. We will see you next time.